Hi guys, so this is going to be a quick video on lipid digestion, absorption and mobilization of these lipids. So the first thing that generally happens is you consume food. And the food you consume is taken through the digestive tract and brought to the intestines, where bile acids break down the large lipid molecules that you consume into smaller lipid molecules such as triglycerols and cholesterol esters. And these smaller lipid particles are packaged into lipoproteins called chylomicrons. Now, what is a lipoprotein? A lipoprotein is just a way through which cholesterols and triglycerides are carried through the body through the blood and through the general system of flow. And the lipoproteins are composed of a phospholipid bilayer, and they have apoproteins on their membranes. Now, apoproteins can be both peripheral and integral. In the case of the chylomicrons that are synthesized initially, this is their basic structure. You have a phospholipid bilayer, you have the packaged cholesterol and triglycerides on the inside, and you have this integral apoprotein. And the integral apoprotein just means that it's shown on the outside and the inside of the membrane. And it's called B48. Now, this is the general structure or the initial structure of the chylomicron. And this is then passed into the bloodstream, and in the bloodstream it picks up two more vital apoproteins, and these are both peripheral apoproteins called apoprotein C and apoprotein E. Now, this is the final structure of your chylomicron, with your phospholipid bilayer, your B48 integral apoprotein, and your two peripheral apoproteins in the form of C and E. And what happens is, now your apoprotein C and E, they both are directing apoproteins. Specifically, C directs this chylomicron to your fat stores, to your adipocytes, and to your peripheral tissues, where you have LPL receptors, or lipoprotein lipases, which then bind this chylomicron, and they bind it, and then the triglycerols from inside the chylomicron that are packaged within it are released through the receptor into the tissues, and they get converted into free fatty acids, and that's where they're stored, and that's where your adipose tissue is, and you store these free fatty acids. So now, after this process occurs, your chylomicron unbinds, and the important thing to note is that the apoprotein C is no longer bound to your chylomicron. It's not there because it was used to transport it to the peripheries. So now your chylomicron is called the chylomicron remnant. It's the remaining part of the chylomicron, because now you only have your B48 and your E apoprotein left. But then now your E apoprotein again directs your chylomicron to your liver, where you have LDL receptors that bind your chylomicron remnant and then take in the cholesterol that's in there and the little bit of triglycerides that's left over into the liver, where your liver can now use them to produce energy, to produce other organic compounds or bile acids. Now, the pathway I just described is the exogenous pathway. As you can see by the X part of the word, it relates the idea that you're taking stuff from the outside, you're taking food from the outside, and you're ingesting it and you're breaking it down into lipids and processing it. But then you also have another pathway, the endogenous pathway. And the end implies that it's from the inside. And this occurs through the liver. So the liver has fatty acid stores, and the liver can then package them into lipoproteins called very low density lipoproteins, or VLDL. Now, very low density lipoproteins, or VLDL, have a very similar structure to the chylomicrons. Now, I'm just going to draw the phospholipid bilayer as a circle to save time, but it looks the same as the chylomicron, with the only difference being your apoprotein that is integral is now B100. Otherwise, it is the exact same with your cholesterols and triglycerides packaged in there. Then your VLDL gets put into the bloodstream, and as from before, it picks up two very important apoproteins, and it becomes the final form of your VLDL, with your cholesterol and triglycerides on the inside, your B100, and your two apoproteins that are peripheral, of course, are E and C. And as I'm sure you've guessed, your C now takes your VLDL and transports it to the peripheral tissues where you have lipoprotein lipase receptors that bind this VLDL and then take the triglycerols from the VLDL into the peripheries and convert it into free fatty acids, and again stores them. And this is the initial or the first step of this very large pathway actually. And after this process occurs, you have two possibilities. The first possibility is that your VLDL unbinds, and as it unbinds, it becomes intermediate density lipoprotein, or IDL. And its intermediate density lipoprotein is because it's lost most of its triglycerides, but not all of them, or not, and it still has a substantial amount. It still has about 30%, 40% of its triglycerides left in there, and you still have your cholesterol. And this is your intermediate density lipoproteins. Now your intermediate density lipoproteins can then go back to your liver and bind to LDL receptors, and again go through the same process as your chylomicron remnants to produce organic molecules or more bile acids. Or your VLDL can stay bound to your receptor and continue losing triglycerides until the point where you barely have any triglycerides left. About 10% is the magic number. And at this point, you can unbind from the receptor, and now what they're called is still have their B100 receptor, but they are called LDL, or low density lipoproteins, because they've lost so much of their triglycerols, and of course they still have their E bound to it. Now, as I'm sure you can see, this shows that this whole process was pretty much to get your LDL, and your LDL is what gave all this fat and all this triglycerol to your tissue. So the function of this LDL was to take tissues from your liver and deposit it into your peripheries, because now you have all this free fatty acid in your peripheries. That was the main function of your LDL. Now your LDL can also go back to your liver and get endocytosed into the liver, or it can go through endocytosis in the peripheries and get absorbed completely. But the point was to deliver these fat stores to your peripheries and to your fat cells. Now, this is the general pathway, but you also have one more component of your endogenous pathway, and that is your HDL, or high density lipoprotein. Your high density lipoprotein is produced from your liver, but it can also get produced from your intestines. And your high density lipoprotein, again, similar structure, phospholipid bilayer, but again, you have a different integral membrane protein, and it's called integral membrane apoprotein. It's called ApoA. And the thing is, there's one really big difference with HDL comparing to everything else. There's pretty much nothing in this package. It doesn't have anything packaged inside. It's very empty. It has a couple of free-floating triglycerols and cholesterols, but in comparison to this, and to LDL and to your chylomicrons, it barely has anything. And why? And I'm going to tell you why. Because what the function of the LDL is, the LDL gets released by the liver and the intestines. It travels to your peripheries, and it picks up your fats. It picks up the triglycerols, the cholesterols, mainly cholesterols, and it picks them up and it puts them inside this phospholipid bilayer. That's why it's empty. Because if you had this completely saturated with triglycerides and cholesterols, how are you going to pick stuff up? How are you going to take in more material to transport, more lipids to transport? And after it picks this up, it then goes back to the liver and then gives all this cholesterol and triglycerols to the liver, so that the liver can again package them and make them into more VLDLs or make them into bile acids or whatever the liver wants to do with it, really. But then something on the side that's also very important, apart from this whole pathway, is to do with LDL. LDL is sometimes considered bad cholesterol because it gave up a lot of its triglycerol, so it pretty much has cholesterol left in it. And the LDL can then go into your peripheries and deposit, instead of getting reabsorbed, it can deposit all this excess fat in your arteries, and the buildup of all this fat kind of develops this plaque. And now, as plaque is there, your blood flow is inhibited. It's made slower. It slows down, and this can cause atherosclerosis. That is why most people consider LDL very bad. It's considered bad cholesterol, but the reality is, it's the main source of cholesterol in your tissues. So it's not really bad cholesterol, it's only bad if you have it in high quantities, which is when it gets deposited. Otherwise, its main function is to come and deposit fats, which you do need in your body. And then the fats can then be picked up from either the peripheries or from your blood vessels by the HDL and taken back to the liver, which is the main function of the HDL, to take the fats back to the HDL. To the liver. And that pretty much covers the entire pathway, but there is actually one more thing that I think I should specify on, is that in terms of the specific transport of the HDL, the way that this happens is you have your peripheries here, and you have your free fatty acids and your cholesterol, and you have a receptor called the ABCA1. And your ABCA1 receptor is what your HDL will bind to. And what the ABCA1 receptor is, it's a flipase. A flipase is exactly what it sounds like. You have free fatty acids inside, and it flips them to the outside. And after it flips them to the outside, the HDL goes, oh, there's fatty acids there, I can go bind to that receptor and pick them up. But the problem is, you can have mutations in this ABCA1 receptor. And a mutation in the ABCA1 receptor would prevent the HDL from binding, and if it prevents the HDL from binding, the flipase still works, and it keeps flipping cholesterol into the cytosol, into the blood, but there's nothing to pick it up, and this is what causes hypocholesteremia. This flipase keeps flipping cholesterol back, and there's nothing to pick it up, so you build cholesterol up in your body, and this is very unhealthy, and again, the buildup of cholesterol would thus lead to hypocholesteremia. So that pretty much covers the entire pathway. I hope that makes sense. And that's it. Cheers.